Hello everyone, welcome back to Exploring the Coast with Hannah. We are on our last video in our climate change series, and we're going to be looking at the LiMPETS program and the long-term data that is helping track climate change. Let's go. Beyond the educational value of the LiMPETS program, which stands for Long-Term Monitoring Program and Experiential Training for Students, the power of the LiMPETS network lies in the large quantity of data that are being collected at over 60 sites and over 600 miles of coastline. Annually, thousands of students and citizens compile baseline data against which future observations will be compared. So how do we establish a baseline? If we understand what is normal in a system, we can then begin to identify trends that could be a result of destructive human activities like trampling, harvesting, pollution, and climate change. Collecting long-term data can be very costly and time-consuming, which makes these types of data sets less common in the scientific community. Since baseline data taken over long periods of time can show gradual or even significant changes in habitats and species abundances, it can provide crucial information regarding changes due to climate change, especially in rocky intertidal ecosystems. As we discussed in our sea level rise and zonation shifts among rocky intertidal species video, LiMPETS has data that is also showing zonation shifts and abundance changes at some of our sites. This graph shows abundance and zonation changes of 3 different species at our Natural Bridges vertical transect site. On the horizontal line, which is the x-axis, it shows the meter marks going from the high zone area, which starts at 0 meters, to the low zone area, which ends at 27 meters of this particular transect at this site. We are going to be looking at sea mussels and surf grasses on this graph. If you look, there are 2 blue lines for sea mussel data. The solid blue line is data taken from 2000 to 2004. The broken blue line is sea mussel data taken from 2010 to 2014. You can see at the 27 meter mark where the average number of squares of mussels present out of 25 is about 21 from data taken from 2000 to 2004. However, if you look at the data taken at the same meter mark from 2010 to 2014, its abundance declined significantly to only about an average of 4 squares of mussels found within that area. The opposite effect happened to surf grasses. As you remember, surf grasses are a low zone dominant species. If you look at the abundance of surf grasses at the 27 meter mark, they were recorded to be about 7 squares from 2000 to 2004. However, the abundance jumped dramatically to about 19 squares of surf grasses found during 2010 to 2014. Since 2013, sea stars along the North American Pacific coast have been declining in great numbers from a mysterious wasting syndrome. The current bout of this wasting syndrome was first documented in ochre sea stars in June 2013 along the coast of Washington state. However, you can see through our LiMPETS data that we saw a decline of ochre sea stars long before the initial die-off in 2013. You can see here on the graph from 2009 to 2013, ochre sea star numbers declined at our 2 Santa Cruz sites, which are at Almar Avenue and Davenport Landing. We saw an initial crash in 2014 at our sites, however, than in 2013. Similar die-offs occurred before, but never at this magnitude and over such a wide geographic area. Ochre sea stars and many other species of sea stars have been affected by the current sea star wasting syndrome event. LiMPETS is contributing data by counting sea stars and searching for signs of recovery. As we discussed in our rising sea surface temperatures and southern species migration video, the sunburst anemone is predominantly a Southern California species. But due to rising sea surface temperatures, it has moved its distribution up the coast. Our LiMPETS data has also shown an increase in sunburst anemones at our sites in Central and Northern California. You can see a large increase in sunburst anemone abundance at our Davenport Landing site in Santa Cruz from 2009 to 2014. And you can also see evidence that the sunburst anemone is also starting to show up at our most northern sites at Pigeon Point and Fitzgerald. Because of the LiMPETS program long-term rocky intertidal data sets, we have been able to contribute valuable data to scientific research. This includes being awarded as a subcontractor with the assessment of rocky intertidal habitats for a California Marine Protected Areas Monitoring Program grant, in partnership with the University of California, Santa Cruz and California Sea Grant by providing total count and size measurement data of owl limpets, sea stars, and abalone to help assess the success of California marine protected areas. LiMPETS has also contributed ochre sea star data with the multi-agency Rocky Intertidal Network's Sea Star Wasting Task Force program. LiMPETS also presented at the World Congress of Malacology Conference in August 2019. This was an international conference where we presented our student-collected data, where we analyzed the impacts of overharvesting on the population structure of owl limpets, where average individual size and abundances were compared between two pairs of marine protected and non-marine protected limpet sites. In 2007, the COSCO Busan, a large container ship bound for South Korea, crashed into the base of the San Francisco Bay Bridge, spilling 58,000 gallons of heavy-duty bunker fuel oil into the San Francisco Bay, and deposited oil on the sanctuary's rocky shores, including Duxbury Reef, which is a LiMPETS site. After the COSCO Busan spill, LiMPETS data were requested by scientists and resource managers to help assess the damage caused by the spill. Thanks so much for joining me today. The next video on Exploring the Coast with Hannah drops Tuesday, August 4th at 11 a.m. on the Pacific Grove Museum of Natural History's Museum to You page.